Are y'all ready? Close your computers. Go ahead and close them, everybody. You don't need the computers today. Alright, how you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And today, we're going to be talking about experimental and theoretical probability. I have other videos with different worksheets about this. Please check them out. And if you're new here, subscribe and turn that notification bell on. And other than that, let's get right into it. So, experimental and theoretical probability. This is still kind of easy, but this is thinking like if we actually have the things that we're going to deal with and actually doing the experiment. Okay, that's why it's called experimental and theoretical probability. So whenever you're in science, whenever you're going to do an experiment, or at least what I remember from science class, from intermediate, from high school, from college, and the university, is that you have to write a theory before you do the experiment to know what you can expect to happen. That's why you do that on science, and this is very similar, but now we're doing it with numbers. So we're going to write a theory to know what we can expect to happen on the actual experiment. So right here it says, experimental probability is the ratio of the number of times an event occurs to the total number of trials. So this is what actually happens. And then theoretical probability is the probability of an event happening based on the possible outcomes. So instead of actually doing the experiment, we're going to test what could happen. So this is what should be expected to happen. And this is also, this right here is simple probability. But the experimental is a little bit different. We're in a formula, which is basically also part of our total. You'll see it says the number of times this thing happens over all the total trials. It's like, for example, if I have a dice and I roll it, what are the chances of getting a 1 on a dice? What, 1 out of 6. But if I roll it 20 times and 1 shows up 3 times out of, how many times did I roll it? 20. That will be 3 out of 20. That's it. That's all we're doing. Okay? So let's see. We have over here a spinner, and we have 3 questions right here. What is the theoretical probability? Again, theoretical is just simple. Of spinning a section with stripes. So first thing we got to do is find the total. How many total sections do we have? 8. So remember, for theoretical probability, it's just simple probability part over total. How many total sections we have? 8. How many are stripes? 1. That's it. But now we're going to convert that into a decimal and percent. Okay? So this is going to be after you do TiVo, because I don't want to spend time on doing TiVo. Top in, bottom out, you divide. Top in, bottom out, you get 0.125. And to convert that to percent, move twice to the right. So this is 12.5%. So this is just theoretical. This is just simple probability. It's that easy. It's the same thing as simple probability. Okay? Or it can be compound. 2 things happening. Like if you're going to have a dice and a spinner, find the compound, and that's going to be the theoretical probability. Okay? It says, what is the theoretical probability of spinning a section with stars? How many sections do we have with stars? With stars? 2 out of 8. Can we simplify that?
Yeah.
1 out of 4. And we know this is 0.025, which is what percent? 25%. That's that easy. Theoretical probability is just simple probability, part over total. Always simplify. Okay? Now the next one is, what is the theoretical probability of not spinning a solid or striped? So how many solids or stripes do we have? 1, 2, 3, 4, and 1 stripe. So how many is that? That's 5, but we want not. So how many are not solid or stripes? I have 1, 2, 3 out of 3 out of 8. Because we're looking for not. Okay? When you do TiVo, you get 0.375, which is what percent? 37.5. Very good. That's all there is to it. That's theoretical. And we're going to go to example 1. Example 1 is going to be the experimental. Okay? So we're going to first find out how many times this happens. So I have the dice and I'm going to toss it 20 times. Okay? So first of all, how many numbers do I have on the dice? No, on the dice. 6. They're right here. 1 through 6, right? Out of the 20 times, how many times did I land it on 1?
1.
No, look at the frequency. 4 times. How many did I land on 2? 3 times. On 3, 5. On 4, 5. And 6, 2. So kind of random numbers, but which one is the one that landed the most? 3. 3 landed the most. I had 5 times it landed on 3. Okay, again, this is just probability. Okay, so it says right here, find the theoretical probability of landing on a 3. So first, we're just going to find the simple probability. If we have a dice, we're only going to look for this at this for theoretical. How many 3s do I have? No, just on the box, on the dice. 1 out of 6. And that's it. And what is 1 out of 6? As a decimal? 16.16 repeating. Because it's repeating. When you do TiVo, it'll keep repeating. It'll be 6 repeating, 1.6 repeating. Okay? So that's just the theoretical probability of landing on a 3. Now, we're going to find the experimental. Now, for experimental, we're going to look at how many times. By the way, if you add all of this right here, the bottom ones, the frequencies, how many should you get? What should you get? What should you get? How many times would you do this experiment? How many times do we do the experiment? 20. So if you add 4 plus 3 is? 7 plus 5 is? 12. Plus 2? 14. Plus 4? 18. Plus 2? 20. That's the number of times that we did this experiment. So this matches up, right? So now, we're still going to do part over total. But in this case, my total is going to be how many times we did the experiment, which is how many times? 20. Now, how many times did it land on 3? Now we're looking at the frequency. How many times did it land on 3? 5 times. And can we simplify this? Yes, we can simplify it by 5, right? So this will be 1 out of 4. And we know this one as a decimal right away, right? 0.25 or 25%. Okay? Again, for experimental, we're looking at the frequency that thing happened divided by how many times you did that experiment. It's still part of our total, but now from the actual experiment. Okay? We're going to do 2 more right here for theoretical and experimental. So it says theoretical. What is the probability? Again, theoretical is just simple. The simple. We're just looking at the dice by itself. For landing on a 5 or 6. We're just looking at the dice. We're just looking at the top. So how many is that? No. How many 5s or 6 do I have total? 2 out of? No, just the dice. 2 out of 6. Can we simplify that? By 2. And you get 1 over 3, which is 0.33 repeating, which is 33.3%. All right, that's the theoretical. It's just a simple. I have 1, 5, 1, 6. That's 2 of them on the dice. And on total, there's 2 out of the 6 faces, right? Now we're going to find the experimental probability. The experimental, we're looking at the frequency. How many times did it land on 5? And how many times did it land on 6? 2. So how many total? So experimental, it landed 4 times. It landed 2 times. So this is 6. 6 out of how many total times was the experiment done? 6 out of 20. Can we simplify this? By 2. So this is what? 3 out of 10. And when you do TiVo, you get 0.3 or 30%. All right, so this is how you do theoretical and experimental probability. Remember, theoretical is just the simple probability or the compound probability, which we didn't have examples on this worksheet. But again, for the theoretical, you're just gonna find whether it's the simple or the compound probability. Remember, if it's compound, we just multiply the 2 simple probabilities across, and you get the compound probability. And then for for experimental, we're gonna do the actual experiment. How many times did that particular thing happen divided by the total number of times we did that experiment. I hope that you learned something today. If you did, please give it a thumbs up. If you haven't, please subscribe and turn that notification bell on. And other than that, let's ride.